Hello fellow UFO hunters and welcome to our channel Sydney UFO Hunters. This podcast we will be discussing about the different generation of night vision technology. Also, what does the stats mean on each of the specifications of these night vision devices. Initially, there are three generations of these night vision devices, starting from the most basic Generation 1 and going to the advanced, which is the Generation 3. Generation 1 you can mostly find in any regular night vision website or eBay or anything like that, while Generation 3 night vision devices are more for military grade uses and purposes and such. Let's discuss about Generation 1 night vision technologies. Generation 1 night vision devices are the oldest form of night vision technology. They have been in use since the 1950s and are best for short-range observation in half-moon conditions. Generation 1 tubes do not have a global standard like Generation 2 and Generation 3, which can result in varying device quality. These devices are suitable for the average person who wants to experience night vision. Generation 1 tubes have a lifespan of around 1000 hours, but they may have blemishes which can appear as black dots in the device's view. In lower light conditions, an infrared illuminator may be required, which can either be inbuilt or standalone torch, depending on the device. Now about Generation 2 night vision devices. Generation 2 night vision devices have a clearer and brighter image than Generation 1. This is due to the addition of the microchannel plate, often known as MCP. The MCP allows for a greater range of detection, better image quality, and ability to work in low light without IR illumination, otherwise known as infrared. Different manufacturers offer varying levels of tube quality under the umbrella of the Generation 2 series. Now, about the Generation 3 night vision technologies. The Gen 3 night vision devices are the top civilian grade night vision technology. They are generally reserved for military, law enforcement, and those who demand the best equipment on the market due to their high price point. These devices offer a tube life expectancy of between 7.5 and 10,000 hours, significantly more than Generation 1 and Generation 2 devices. The quality of Gen 3 tubes is measured by the figure of merit, FOM, which is calculated by multiplying the IP/mm with the signal to noise ratio SNR. I will discuss this further in the next section. The image produced by high quality Generation 3 night vision devices is exceptionally clear, crisp, and bright. Generation 3 devices perform well in low light conditions without IR illumination. Many models offer the option of having an auto-gated or a manual gain tube. Now we can discuss the different specifications that these night vision devices utilize. Number 1. Image Intensifier Tube, otherwise known as IIT. IIT is a tube which amplifies the available ambient lighting conditions by speeding up the electrons of the incoming light. Night Vision Generation 3 has the best IIT. Number 2. Objective Lens, otherwise the specifications of F/number. An F number is a measure of the light gathering ability of an optical system such as a camera lens. It is calculated by dividing the system's focal length by the diameter of the entrance pupil. Number 3. Ocular lens, otherwise EFL, number/millimeter. It is a measurement of the distance between the optical center of a lens and the image plane where an object being viewed appears in sharp focus. A shorter EFL means a wider field of view, but a lower magnification, while a longer EFL results in a narrower field of view but higher magnification. Number 4. Diopter. The diopter is a unit of measurement used to quantify the the refractive power of a lens or optical system. The operator value of a lens indicates how much light it converges, for example, to come together or meet at a common point, or diverges, for example, to spread apart or move away from a common point, and it is defined as the reciprocal of the focal length in meters. Number 5. Line pairs per millimeter. Line pairs per millimeter is a measure of the spatial resolution of an optical system, such as a camera lens or an image sensor. Therefore, the higher the line pairs per millimeter, the higher and better the resolution. Number 6. SNR. SNR determines how usable your signal will be. A higher SNR value means the signal is clearer. Number 7. FOM, otherwise known as figure of merit. The figure of merit is used to determine the overall performance of the image intensifier tube, and is calculated as a product of the image intensifier's resolution and signal to noise ratio. I know it can get quite confusing talking about all these different specifications, but generally you would like to focus on line pairs per millimeter, otherwise as known as LP/millimeter, the SNR, and the FOM, figure of merit. Just focusing on these three sections can easily help you determine the quality of the night vision device and the effectivity of its use. We are now going to look at the three different generations, generation 1 to generation 3. The first one is the Pulsar Edge GS. The specs are resolution 42 LP/millimeters, maximum range 110 yards or 100 meters, field of view 36 degrees, and the max range is 65 yards to 59 meters. The next one is the Nikon NV66 Generation 2 Plus Night Vision. The specs are resolution 56 LP/millimeters. The signal noise is 18 minimum. Maximum range 200 yards or 182 meters. Field of view 40 degrees. And max range 146 yards or 133 meters. Now it's for the big guns. PVS-7 Generation 3 Auto. Resolution 64 LP/millimeters. Signal to noise 21.1 minimum. Maximum range 400 plus yards or 365 plus meters. Field of view 40 degrees. And at max range 291 plus yards or 266 plus meters. These typical Generation 3 night vision devices are often required some kind of special licensing, as they are military grade. Thank you for listening to our podcast. Next time, we will discuss the general night vision devices which are available to everyone in today's market. And remember, together we learn.